Okay, let me ask you this. Does this ring any bells? You click on a dashboard, maybe Power BI or Tableau, and you literally have time to go make coffee while it loads. Or, your Redshift setup used to be pretty quick, but now it feels like wading through treacle because your data's grown, more people are using it.
Oh, absolutely. That's a story we hear a lot.
If that sounds like you, well, you're definitely in the right place for this deep dive. Because Redshift, while it's powerful, it doesn't just stay fast on its own when you scale up. It needs tuning.
Right. It really does. Redshift is so central for, enterprise reporting, analytics, BI, loads of crucial stuff. But yeah, like any engine, put more load on it and you start seeing those signs of strain.
What kind of signs are we talking about typically?
Well, the classic ones are queries just taking longer and longer,
Hmm.
queue times building up, maybe costs start creeping up unexpectedly,
And frustrated users, I bet.
and definitely frustrated users, yeah. The main point really is that waiting for it to actually break or slow down to a crawl, that's the expensive way to handle it. You need to be proactive with tuning.
Okay, so being proactive is key. We get why it matters, but let's dive into the how. If someone's facing these slowdowns, what skills do they actually need? What's the expertise required to diagnose and fix these Redshift bottlenecks?
Good question. I tend to break it down into about four main areas of expertise. First up is what I call bottleneck diagnosis. It's not enough to just feel like it's slow. You need proof.
Right, you need to pinpoint the cause.
Exactly. This means getting comfortable reading an explain plan, understanding what Redshift is actually doing step by step behind the scenes for your query. And you also need to know how to dig into Redshift's own system tables. Things like SVL query report or SDLWLN query.
The system views to see what's really happening.
Precisely. They help you figure out, is the bottleneck I/O, is it CPU bound, is it running out of memory, or maybe even hitting network limits. It's like being a detective for your data warehouse.
Got it. Like reading the system's vital signs.
Hmm.
So, okay, you've diagnosed the what, what's next? How do you fix it?
Well, that leads straight into the second area, query optimization. And here's the thing. Writing SQL that flies on Redshift isn't always the same as writing, say, standard PostgreSQL.
It has its own quirks.
It does. A really big principle is filtering data as early as you possibly can in your query. Think about it. The less data Redshift has to chew on at each step, the faster the whole thing runs.
Makes sense. Less data, less work.
Exactly. And join strategies are huge too. You need to understand how Redshift is joining your tables. Sometimes you might see like a broadcast join happening when you don't expect it. That's often a warning sign.
A warning sign of what?
Often it points to a problem with how your tables are physically laid out, specifically the distribution keys we can talk about. Also, sometimes you might look into using approximate functions.
Approximate functions, like for counts and things.
Yeah, things like approximate count. If getting a very close answer incredibly fast is better for the business than waiting ages for a perfectly precise one, they can be lifesavers. And obviously, avoiding really heavy, complex subqueries where possible. Think Redshift-friendly SQL.
Okay, Redshift aware SQL. I like
Yeah.
that. You mentioned table layout just now. That brings us to the physical design, right?
Absolutely. That's the third key area. Physical data design. Primarily, this means understanding and choosing your distribution styles and sort keys wisely.
The dist key and sort key.
Yeah. Think of the dist key, the distribution key, as the rule that decides which slice or node in your Redshift cluster gets which rows of your table. If you choose a dist key based on how you frequently join tables, ideally the columns you join on.
Then the data you need for the join is already on the same machine.
Exactly. It minimizes Redshift having to sling potentially terabytes of data across the network between nodes to perform the join. That network shuffling is a major performance killer.
Okay. So a bad disk key choice basically creates a network traffic jam inside the cluster.
You got it. And sort keys, well, they define the order data is stored within each node. If your queries often filter on a date range, for example, having a sort key on that date column lets Redshift skip reading massive blocks of data it doesn't need.
Like an index, but for blocks of data.
Sort of, yeah. It dramatically reduces I/O. And the crucial thing about disk key and sort key is that they are foundational. Getting them right early is much, much easier than trying to change them later when you have huge amounts of data.
Right, like planning the foundation of a building properly. Okay, so diagnosis, query tuning, physical design. What's the fourth piece?
The fourth piece is workload management,
WLM.
WLM. The traffic cop.
Hey, yeah, that's a great way to put it. It's essentially the air traffic control system for your cluster. You've got potentially lots of users, lots of different queries hitting Redshift all at once, dashboards, ETL jobs, ad hoc analysis. WLM is how you manage all that. You set up queues, define priorities, allocate memory, set concurrency limits, how many queries can run side by side. So it stops like one massive query from hogging all the resources and blocking important reports.
Precisely. You can set up rules, maybe using query monitoring rules, QMR, to automatically manage runaway queries or prioritize critical workloads. Good WLM configuration ensures your key dashboards refresh on time, even when the cluster is busy. It maintains stability and predictability.
Okay, that makes a lot of sense. So pulling it all together then, if you're a data engineer, an analyst, anyone working hands-on with Redshift, mastering these four things, diagnosing bottlenecks, using the system tools, writing optimized Redshift SQL, getting that physical data design right with disk keys and sort keys, and configuring WLM effectively, that skill set is incredibly valuable.
It really is. It can make you indispensable to your team, ensuring the platform scales and delivers insights reliably.
And flipping that perspective for, say, tech leaders or business stakeholders,
Right.
understanding why investing in this tuning expertise matters, what's the payoff for them?
It's pretty direct, actually. The ROI is clear. Faster insights, which means quicker decisions, fewer performance crises that disrupt business users or delay critical reporting, and ultimately a lower total cost of ownership for your analytics platform because you're using the resources more efficiently. You might even avoid needing to scale up the cluster hardware quite so soon.
Better performance, happier users, controlled costs.
Yeah.
Makes sense. So if you're listening and thinking, okay, I need to get better at this or my team needs these skills, we do have a more detailed article that dives even deeper into these optimization techniques. We'll link to that.
Yeah, definitely check that out.
And if you're maybe looking to bring in some specialist help, maybe for a specific project or even longer term, a great resource is Curate Partners. They really specialize in connecting companies with folks who have deep Redshift tuning expertise.
They know the domain well.
Absolutely. Well, that about wraps up our deep dive for today. Thank you so much for tuning in. If this was helpful, please do subscribe and maybe share it with your data team or colleagues who wrestle with Redshift.
Thanks, everyone.
And just one final thought to leave you with. Remember that a high-performing Redshift cluster isn't just something you set up and forget. It really needs active care and feeding constant tuning and optimization to keep delivering value as your data grows.